In this second installment, we will discuss repeatable deployments. GS2 deploy is a GS2 feature that enables repeatable deployments. I would like to focus on GS2 deploy. To begin with, what is repeatability? As the name implies, reproducibility is the ability to create the same situation even after repeated execution. In game servers, it is common to prepare multiple environments, such as a development environment, a staging environment, and a production environment. If reproducibility is not maintained, it will be difficult to create new environments. In the server infrastructure industry, there is a term called infrastructure as a code. In the past, when setting up a server, middleware was installed by typing commands each time. However, this is not reproducible, and setting up 100 servers can take an inordinate amount of time. In addition, there might be servers where the application does not run properly due to omissions in the configuration. Infrastructure as a code was created to eliminate these problems. The idea is to set up the infrastructure in code, just like programming. At first, it was like applying a recipe with recorded commands to a server, but this has changed over time. The most significant change is the concept of idempotency. Idempotency is the property of being able to apply an application repeatedly without error or incorrectness, and to have it stay in the same state. In other words, when an application is installed, if it is already installed, it is assumed to have succeeded without being installed. This way, it can be used not only when setting up the server for the first time, but also when updating it. Moreover, whether updating a server that has not been updated in a month or a server that was updated yesterday, both will be up to date if deployed using the same configuration file. Rather than listing commands for installation, such a configuration file would be a list of application types and versions that you want installed. Such a configuration file is called a declarative definition file. GS2 deploy's declarative configuration file is named template. The environment is created by writing a template and uploading it to GS2 deploy. The template file declaratively defines the resources required by GS2, the type of namespace to manage accounts, and the type of namespace to manage items. In addition, master data such as what types of items are available and possession quantity limits are also included here. GS2 deploy templates can also be updated. When updating, GS2 deploy detects differences from a last uploaded template. If a resource has been added, it is created. If a resource has been updated, it is updated. If a resource has been reduced, it is deleted. Let's look at a sample template file. This is a template file that creates a GS2 identifier user, assigns an application access policy, and issues credentials. The most important part of this template is the resources section. This is where you declare the resources you want GS2 deploy to create. This template file declares 3 resources. First is the resource name. Identifier application user is the name of the resource, and you can give it any name you like. Type specifies the type of resource to be created. In this case, we are specifying that we want to create a GS2 identifier user. In the Properties section, we set the parameters required to create the user. Let's delve into the parameters. We specify the name of the user. Now we can code what we created in the previous session by manually manipulating the management console, just like programming. This means that GS2 deploy now has a repeatable deployment using infrastructure as a code. Next is the resource declaration that assigns the security policy to the created user. A new element appears, dependent. It declares that the resource depends on another resource. Since a user must be created before a security policy can be assigned to a user, we declare that the resource depends on the user's resource in this way by specifying the name of the resource. With this declaration, GS2 deploy delays creating resources for security policy assignment until after the user has been created. Without this declaration in some cases, GS2 deploy may try to assign the security policy before creating the user, and the deployment may stop because the assignment failed because the user does not exist. The parameters for security policy assignment are the name of the user to whom the security policy is assigned and the ID of the security policy to be assigned. Finally, there is the resource declaration that issues the credentials for the user. There are no new elements in particular. Finally, there is the output section. Here you can record the results of the deployment process. The client secret of the credential is only known at the time of issuance, so if it is not recorded here, there is no way to check it. The statement gethatter is a call to the gethatter function available in GS2 deploy. This is followed by a space followed by the name of the resource whose information is to be obtained, and the property to be obtained is specified in the return value of the Resource Creation API. The definition of result in the Create Identifier API, which can be found on the documentation page, can be used as a reference at this time. The client secret is in the root hierarchy of the result, and the client ID is in the item property of the identifier type. Therefore, the part that records the client ID is the resource name, item cliented, client secret, and the client secret is recorded as resource name, client secret. This concludes our lecture on continuous deployment in GS2. Now, let's create the resource. First, create a template file. Use the template for creating credentials from the GS2 documentation as a template to start with. The username to be created should be user to match the previous session. First, let's configure GS2 account. Create a GS2 account namespace named account. Next, let's set up the GS2 key encryption key. Create a GS2 key namespace named key. Next, create an encryption key. Named authentication key. Note that the creation of the encryption key must be done after the creation of the namespace, so you must set up the namespace independent. Now let's upload the template from the management console and set up the environment. All previously manually created resources have been deleted. Select Deployed greater than stacks from the side menu. Select Create New Stack. Specify app as the name of the stack and upload the template file. Looking at the list of events, you can see that the creation is in progress. Just to be sure, check that the resource has been created properly. In GS2 account, we can confirm that a namespace named account has been created. Next, under GS2 key, we have confirmed that a namespace named key has been created, and that an encryption key named authentication key has also been created. Finally, in GS2 identifier, we have confirmed that users' credentials and policies have been assigned. Returning to the Stack Details page and opening the Outputs tab, you will see that the client ID and client secret set in the Output section have been recorded. Using this client ID and client secret, verify that the previously created program works. Sets the account information created in the GS2 account namespace that was manually created last time remains. Delete the player prefs and execute. It worked properly. Confirming that the account was created in GS2 account completes all the verification work. We were able to automate the environment setup that we set up manually last time. Now it is easy to prepare the same GS2 setup for other accounts and projects. Template uploads can also be performed using the GS2 SDK without going through the management console. This can be successfully used to manage templates in a source code version control system and automatically reflect them in the development environment when automated tests pass in the develop branch. We have seen that there is a function called gethatter, but are there any other useful functions? The first is the alias function. Let's look back at the template we created this time. There are 3 username declarations, and it looks like they are not easy to maintain. In such cases, alias is a function that allows you to use the value with an alias, just like a variable. If we apply alias to this template, it will look like this. Add an alias declaration in the global section. Below that, declare the alias name and value. You can then use the alias by specifying the alias name in the section where you want to use the alias. Now you have one place to change the username when you want to change it. The gethatter function can do more than just refer to the value of a resource creation result. First, it can retrieve the region name from a running GS2 region. Second, it can retrieve the owner ID, which consists of the running GS2 account plus project name. If you need to embed a GRN in a template, you can use the value obtained from this function to increase the portability of the template. Finally, there is the join function. The join function allows you to join strings together. The join function accepts a single array parameter. The array must consist of 2 elements. The first element specifies the string to be added to the join when joining strings. The second element is an array of strings to join. In this example, the GS2 log namespace GRN is assembled and specified using the join function. Preview of next article. Now that you have created a program that logs you in, I wish you would have explained more about the features that can be used in games rather than talking about complicated deployments. Some of you may have felt that way, so here we go. In the next article, I will explain how to manage item ownership on the server. Please look forward to the next installment.